Bismillahirrahmanirrahim. Welcome, my dear students. Welcome back, students of grade 9, third preparatory, for a new lesson, radioactivity and nuclear energy. You know that you have studied before the atom of any element consists of a nucleus which contain positively charged protons and neutrons which are neutral, and around the nucleus there is electrons revolve around the nucleus in a very high speed, and the electrons are negatively charged. So we have three different particles: protons, which are positively charged, electrons, which are negatively charged, and the neutrons, which are neutral or uncharged. And we know that the mass of the atom is concentrated inside the nucleus. Why? Because protons and the neutrons have bigger mass if it is compared to electrons. The electron's mass is very small. It can be considered a negligible mass. So the mass of electrons are very small, so it is considered negligible. So the mass of the atom is concentrated inside its nucleus, which contain protons and neutrons. And the physical and chemical properties of any element depend on the atom. Depend on the number of electrons, the number of protons, and the number of neutrons. Some atoms have a small number of protons and the electrons and neutrons. These are light atoms. And some atoms are heavy atoms. They have big number of protons and neutrons and electrons. And the chemical activity of an element depends on the number of electrons. The number of electrons, or especially the outermost energy level electrons. You can know this element is a metal or non-metal by the outermost energy level electron. If it has 1 or 2 or 3 electrons, you say it is a metal. It is a metal element. If it is 5 or 6 or 7, you say it is a non-metal. But the nuclear reactions, not the chemical reaction, the nuclear reactions depend on the nucleus, depend on the number of protons and the number of neutrons, protons and neutrons. So when we are talking about nuclear reactions or nuclear energy, we are talking about what inside the nucleus of the atom. We are not talking about electrons. Electrons are responsible only for the chemical reactions. So when we are talking about nuclear energy, it is the energy stored inside the nucleus of the atom. If you ask me, give reason, the nuclei of atoms of stable elements are coherent, although the presence of repulsion force inside them. The answer is why the stable elements are coherent, have coherent nucleus. The nucleus is stable. Coherent means stable or fixed. Due to, of course, the answer due to another force called nuclear bending force. Against what? Against the repulsion force. So if we look at this picture, we can see the violet color particles, which are protons in purple or violet, and the neutrons in red color. We can see here a repulsion force between protons and each other because all of them have positive charge. But there is another force to overcome this repulsion force, to make the atom stable, to make the nucleus stable. This is called the nuclear bending force against the repulsion force. And the nuclear bending force inside the nucleus keep the nucleus stable. Keep the nucleus stable. And keep the nucleus components together. Doesn't separate it from each other. So overcoming the repulsion force, that present between positively charged protons depend on the nuclear bending force. This is a very important force, nuclear bending force. So how can we define nuclear bending force? The nuclear bending forces, they are the forces that are necessary to bend nucleus components together and overcome the repulsion force that are present between the positively charged protons and each other. So the nucleus of the atom is coherent and stable due to the presence of nuclear bending forces. The nuclear bending forces are considered the source which provide the atom with huge energy, which is called nuclear energy. So the atom's nucleus is considered as the energy store. The energy store. This nucleus is considered an energy store. Let's move to radioactivity phenomenon. Some elements are stable and other elements are called radioactive elements. How do humans discover this? Some elements are stable and others are radioactive. A scientist called Henri Becquerel in the year 1896, this French scientist discovered that there is an emission of unseen rays from the uranium element. This emission of rays, unseen rays, can penetrate the solid objects. It can penetrate the solid objects. If you look at this picture, he put a piece of uranium and he put it over a solid object, maybe a piece of metal or a piece of rock, and put a photographic film below it. He observed that the photographic film has the rays penetrate the solid object and go to the photographic film and make an image on the photographic film. After that, he named this phenomenon as radioactive phenomenon or radioactivity phenomenon, and he named the uranium element radioactive element. Okay, so what is meant by radioactivity? In the periodic table, there are some elements, some atoms of some elements, their nuclei are very heavy. They are unstable. They have unsuitable number of neutrons, big number of neutrons. So the atom is heavy. This big number of neutrons, for example, if you look at uranium, the atomic number is 92. So the number of protons is 92, number of electrons also 92. But the mass number or the atomic weight, 238. So if we make the minus 238 minus 92, you will find that the number of neutrons is very big compared to the number of protons. Maybe protons 92, but neutrons may be 146. So it is a big difference. Big number of neutrons make the atom unstable. It has excess energy and excess mass. And this is called the radioactive element. So the radioactive element can be defined as they are elements whose atoms' nuclei contain a number of neutrons more than the number required for its stability. So the number of neutrons are very big, so the atom is unstable. From examples of radioactive elements, we have a lot of examples, and some of them are radium, selenium, zirconium, uranium, rubidium, polonium, and cesium. Radium, cesium, selenium, polonium, zirconium, rubidium, and finally uranium. These elements are heavy elements. These elements are radioactive elements. These elements are unstable elements. So what does the atom do to release this energy? It should do something to release this heavy energy and heavy mass. What happened here? The atom nuclei of radioactive element emit invisible radiation, may be alpha particles or beta particles or gamma rays automatically. Why does the atom or the nucleus of the atom emit this radiation? To get rid of excess energy, to achieve a more stable composition. To get rid of excess energy to achieve more stable composition. This process is called radioactivity phenomenon or natural radioactivity. So radioactivity phenomenon can be defined as the following. It is a spontaneous decay of the atom's nuclei of some radioactive elements present in the nature in attempt to achieve a more stable composition. So, what happens if the number of neutrons in an atom of a nucleus of an element increase more than the number required for stability? Of course, the energy will increase, so the atom nucleus emit invisible radiation to achieve more stable composition. Type. Give reason. Uranium element is considered a radioactive element because the uranium has big number of neutrons, 146, and only 92 protons. The big difference here in the number makes the uranium atom is unstable. It contains a number of neutrons more than the number required for its stability. So it emits this radiation, release some energy and release some mass. It make or release this invisible radiation. Another give reason, the nuclei of radioactive elements are unstable. Of course, the answer, due to the excess energy because the number of neutrons more than the number required for its stability. Artificial radioactivity. We have to know that there is two sources of radioactivity, natural radioactivity and artificial radioactivity. The natural radioactivity comes from elements in the Earth's crust. Okay, like uranium, rubidium, cesium, these elements, some of them are found in the Earth's crust and some of them are made artificially. But the radioactive elements found in the Earth's crust make radiation. And also sometimes the radiation comes from outer space, cosmic radiation. It's called cosmic radiation. Okay, this is natural sources of radiation. But what are the artificial radioactivity or the artificial sources of radiation? We can make artificial radiation by nuclear reactions. This happen by two ways. A way which can be controlled and another way which cannot be controlled. The artificial radiation or the artificial radioactivity which can be controlled, this happen in nuclear reactors and it is used in safe uses. But the uncontrolled or non-controlled artificial radioactivity, this happen in the nuclear bombs and in military uses we cannot control. So the artificial radioactivity can be defined as the following. It is a radiation of nuclear energy that is released during nuclear reactions, either from nuclear reactors or from nuclear bombs. Okay, the safe uses of nuclear energy. We have many purposes we can use the nuclear energy in it, like medical field, agricultural field, industrial field, electricity generation field, space exploration field, and drilling field. Medical field in the beginning, it is used, the nuclear energy can be used in diagnose and treat diseases like cancer disease. Diagnose and treatment of cancer. In agricultural field, in eliminate pests, to destroy pests, the agricultural pests, or the agricultural maybe worms or insects, we can destroy them by radioactivity. And improve some plant races. Improve some plant races. Third, in industrial field, to convert sand into silicon sheets, which is used in manufacturing computer processors and programmed electric circuits that are used in electric appliances like processor, RAMs, and motherboard, and so on. To discover defects in manufactured products. We can discover defects such as the welding defects or something like this in some products. Number 4, electricity generation field. To heat water, radioactivity can be used to heat water, or nuclear energy can be used to heat water, produce steam or vapor. This steam can be used to operate turbines and electric generators to generate electricity. Then, number 5, space exploration field. The radioactive elements, radioactive materials are used as a nuclear fuel for rockets that fly in space. You can use it as radioactive fuel. Finally, number 6, drilling field. Drilling for petroleum and underground water. Also, we can use a nuclear energy. History about the scientists who discovered the radioactivity and the nuclear energy. We have a great Egyptian scientist called Ali Mustafa Musharrafa. This Egyptian scientist was famous in the time of Einstein. He works with Einstein, and Einstein himself described Ali Mustafa Musharrafa by a great description. He say that he is one of the greatest physicists in the world. This description for Dr. Ali Mustafa Musharrafa by who? By the great scientist Einstein. Dr. Ali Mustafa Musharrafa has a great theories in the field of atom and radiation. Basics of manufacturing the atomic bomb were based on his theories. He gave his objection to the development of atomic bombs. He make the theories, but he make objection to use it in making nuclear bombs and nuclear weapons. And he called for necessity of exploiting the atom and the radiation for benefits of humanity, not from destroying of humanity. We will stop here, my dear sons, and we will continue talking about radiation and pollution and the harms of radiation in another video, inshallah. Thank you very much. I hope you listen carefully to this lesson and read it carefully. Until we meet again, goodbye.